So, conductive abnormalities. Um, you should understand that conduction abnormality, blockage, complete or incomplete, can occur theoretically in each part of conductive system of the heart. It can be on the region of sinus atrium. It can be in the place of tracts between sinus node and AV node. It can be inside AV node blockage. It can be blocked on the region of right bundle branch, left bundle branch, total left bundle branch, left anterior branch, or left posterior branch. And we have different ECG manifestations in each localization of this blockage. Sinus node blockage. It's the simplest variant. In this case, electric impulse from sinus node can't go to atriums. In this case, we have normal PQRS complex for electric impulse that passed from from sinus node. Then next normal complex, and then we have absence of any electric activity inside the heart. We have no P wave, we have no QRS complex T wave because there are no impulses, there is no electric activity of atriums during this period of time. And then we have again normal functioning, normal electric activity of the heart. The sign, ECG sign of ASA block, sinus node blockage, is the absence of PQRS complex, and this RR interval is equal to double normal RR interval. This RR interval is double normal RR interval. Then AV blockage. We have 3 degrees of AV blockage. First degree is minimal degree of AV blockage, is characterized by the presence of prolongation of PQ interval. Only prolongation of PQ interval more than 0.12 milliseconds. That's it. There are no absence of QRS complexes. There are no clinical signs. Only ECG finding as prolongation of PQ interval. As usual, the patient may not know about this pathology presence. AV blockage second degree is divided into 2 subgroups, Mobitz 1 and Mobitz 2. Mobitz 1 is characterized by prolongation of PQ interval from complex to complex. This is PQ interval, then prolonged PQ interval, prolonged PQ interval. It's P wave without QRS complex. Then PQ interval, prolongation of PQ interval, prolongation, then P without QRS complex. P without QRS complex. That's called Mobitz 1 AV blockage second degree. Mobitz 2 is characterized by fixed PQ interval. There is no prolongation of PQ interval from complex to complex, but also we have absence of QRS complex after some P waves. It's the P wave without QRS complex. PQRS, PQRS, P without QRS complex. PQRS, PQRS, P without QRS complex. It's called Mobitz 2 AV blockage second degree. Next one, AV blockage of third degree, complete AV blockage. What does it mean? It means that electric impulse doesn't go through AV node, and we have, as a result, we have two rhythms: rhythm of atriums and rhythm of ventricles. On ECG we have also two rhythms. P wave reflects the rhythm of atriums, and QRS complex reflects rhythm of ventricles. QRS complex can be normal, widened, deformed. It's unpredictable shape of QRS complex in this case. And we have two separate rhythms. There is no some binding between P wave and QRS complex. We have separate rhythm of ventricles that is less frequent than rhythm of atriums. As usual, we have atrium frequencies about normal 70-80, and ventricular rhythm up to 30 to 40 beats per minute. Bundle branch blockage. The first variant is right bundle branch blockage. In this case, we have some blockage of right bundle branch that is responsible for right ventricle. In this case, we have contraction of left ventricle at first, and then electric impulse goes around this area of blockage through normal myocardium, not through a conductive system, but through myocardium. That's why we have deformation of QRS complex due to abnormal spreading of electric impulse. It's the first sign of blockage. We have the first sign. We have deformation of QRS complex. We speak about right bundle branch, and we see deformation M-shaped form of QRS complex in the right chest leads, V1 and V2. Right bundle branch, right chest leads. Deformation, M-shaped deformation. It's the first sign. Next one. If we speak about right bundle branch blockage, we will have right electric axis of the heart deviation or shifting, right shifting. In this case, if you will check, you'll find severe right shifting. It's the second sign of right bundle branch blockage. In addition, you can check for duration of QRS complex. It's important to make a conclusion: is it complete blockage or incomplete? If we speak about complete bundle branch blockage, right or left, we have widening of QRS complex. Widening more than 0.12 milliseconds. In this case, we have non-widened QRS complex. It means that the patient has incomplete right or incomplete right bundle branch blockage. Next variant, total left bundle branch blockage. The same situation. We have left shifting to the side of bundle branch that is blocked. Based on these leads, you can analyze and you will see the left shifting. We have specific this M shape with high R wave in left chest leads, V5, V6, and the same sign of the complete or incomplete blockage. If it's more than 0.12 duration of QRS complex, 0.12, it's complete blockage. In this case, it's less than 0.12 milliseconds. It's the incomplete left bundle branch blockage. But sometimes we have situation when not the whole left bundle branch is blocked, but only anterior part, for example. In this case, please turn off microphones. In this case, we have only one ECG sign. It's the severe left shifting of electric axis of the heart. It's the single ECG sign of left anterior part of left bundle branch blockage. There is no curious deformation or widening. It's only shifting of electric axis of the heart. Next variant. Blockage of right bundle branch and anterior part of left bundle branch. So-called bifascicular blockage. Bifascicular. What can be found in this case? We see signs of right bundle branch blockage like M shape of Keras complex in right chest leads V1, V2, but we don't have right shifting of electric axis of the heart. We have left shifting. And based on the position of electric axis of the heart, we can make a conclusion about additional blockage of anterior part of left bundle branch in addition to right bundle branch blockage.